folks, welcome back to another video. Today we're looking at question 875, Koko eating monkeys. The way we'll be solving this problem is by using binary search. When I started looking at this problem, my first approach was to actually play around with the numbers that are given to us, like min and max. But that didn't really work because in future test cases, we see that the numbers that are given to us are really, really large numbers. And obviously moving down by one number or two numbers doesn't really help, and it exceeds the time limit. So there's a reason why we'll be using binary search. So let's get started. So let's set our limit, like the left limit and the right limit. So left limit, we at least need to eat one banana per round. So we'll set left to be 1. The right, let's set it to be the maximum. So in each round, the maximum that you can have is 10 to the power of 9. So let's set that up as the right. And after that, we just need to, so we need to have a while loop, right? So while left is less than or equal to right, we need to keep looping. And we need to have a method that checks for a given count of bananas. Does it stay under 8 or not? So let's call that as like a dummy method right now, and then call it if check. And what are the things that we need to pass? We need to pass the the piles array. We need to pass h, and we need to pass the mid value. Oh, right. Yeah, let's call it a mid, right? If this happens, we need to do something, if not something else. So let's set up actually like the mid value first. So in this case, it would be int mid would be equal to, so binary search, I'm sure you folks have done these problems before. So it'd be left plus right minus left divided by 2. So basically what you're trying to do here is you're just trying to get the mid value. So if we check that Koko can finish the number of bananas in the given number of hours, what we'll try to do is we'll try to minimize that by changing the right value to mid minus 1. Is it possible for us to eat less per hour? So how do we do that? We actually do that by setting the right limit to mid minus 1. If it's not possible, we need to increase it. So it would be left would be equal to mid plus 1. Awesome. And in the end, you'd return the left value because we know that we want to return the least number of bananas. So let's set up the dummy method that we actually try to set up here. So it would be Boolean check and then 3 parameters, right? So it would be int, let's grab p, and then what's next? Int h, and int, let's just call it count, even though we're taking it as mid. All right, so let's take the current, the number of rounds that we need to take as 0. And next up, what we have is we need to actually iterate through all of the values. So it would be int, let's just call it current in p. What do we need to do? So it would be, we need to eat the number of bananas, and we can go by one index to the next. What we can do is the sum we can just increment it by current divided by count, right? And there is a possibility that there's a remainder there, so we need to check for that. So if current modulus count, if it is not equal to 0, as in there is a remainder, so we would need to add the number of times we're actually digging into the same pile again by 1, right? And after that, once we've actually incremented the number of times we have to look at a given pile, if the times that we actually have gone, if it is greater than h, that means the limit, we need to return false, right? If not, if it actually goes through all of the rounds, we know that we can eat all of the bananas in each hour, so you'd return true. So that's pretty much the problem. Let's try compiling this. First few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the solution is n multiplied by log m. So n here would be the number of times, the number of piles, and log m would be the space in which we are looking at. So basically, we start with left and right, and we keep like moving into halves every single turn. So that's the reason why the time complexity is n log m, and the space complexity is O1, since we are not really using any additional space to track any data. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate that. Definitely keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon. Bye.